All right, so we are going to learn about more tangent line properties. And so this one is actually not bad and pretty easier. So another property, if you have a tangent line, so if two segments from the same external point are tangent to a circle, then they are congruent. So what that means is B is our external point, and you have a line segment coming from A to B, and you have a line segment from B to C, and we notice they're both tangent, then we know that AB is congruent to BC. Okay? And that's what they said us right here. So if you have like a birthday hat and two tangent lines, they are both congruent. Something else that happens is if you do that 3 times. So for example, I've got a birthday hat here, I have a birthday hat here, and I have a birthday hat here. So if a polygon is circumscribed around a circle, then all of these sides are tangent. And if they're tangent, I know this piece is equal to this piece, and this piece differently is equal to this piece, and this piece is equal to this piece. Okay? So lots of congruent things. So let's look at some example problems. The directions say, find each value or measure. Assume that the segments that appear to be tangent are tangent. Okay, so I don't have a radius connecting to show that it actually is tangent. So I'm just going to assume that this is congruent to this because they are coming from the same external point. So to solve for x, you're going to say 8x minus 19 is equal to 5x plus 23 and solve. We have variables on both sides. So you can do this problem 4 ways correctly. I'm going to go with adding 19 to both sides. Drop down your 8x equals 5x, and I'm going to get 42. That is a plus. Now I'm going to move my x's to the left, so subtract 5x from both sides. My handwriting is terrible today. 3x is equal to 42. Divide by 3 on both sides, and you will get x is equal to 14. Okay? For time's sake, 11 looks a whole lot similar, so I'm going to skip it, but it does want you to solve for PQ, so once you find your side length, you can substitute it back in to figure out how long it is from B to C or A to B. Okay, so you can try 11 on your own, but let's keep going. All right, looking at the next problem. Again, lines that appear to be tangent will be, so ST is a tangent line, so I'm going to make a congruent mark. SU is a tangent line, so I'm going to make a congruent mark. Notice SV is not a tangent line. That would be a secant line because it goes through the circle. Okay, so first off, I'm going to go ahead and solve for x because these two pieces are equal. So let's say 10x minus 41 is going to equal to 4x plus 7. Let's add 42 to both sides. Don't know why I did 2. That is definitely a 1. Subtract 4. 6x will equal 48. And 6 divided by 48 is going to be 8. All right. So unfortunately, I'm not done. It wants me to find SV. So I don't even have an equation for that. So what I'm going to do is I know that this is going to be tangent because this line appears to be tangent and it told me to assume it. Now I have a right triangle. I know my base is a radius as well over here. So I know my base is going to be 17. I do not know this value of SV, but I can figure out my leg height by plugging in 8 into this piece. So if I plug in 8, 4 times 8 plus 7 is going to give you a length of 39. So I have a right triangle with a leg of 39, a base of 17, and I'm trying to find the hypotenuse. So this would be a case where I'm going to use the Pythagorean Theorem. Your a squared plus b squared is equal to c squared. Now your hypotenuse is always opposite the 90, so that would be my side SV, which is the one that I don't know. So I'm just going to call that my x. Your a and your b are the legs of the triangle. And so I got 39 squared, and then I have a 17 squared. And that will equal up to your x squared. And so now I just have to solve it. So 39 squared and 17 squared, if you type that in the calculator, you will get 1,810 is going to be equal to your x squared, square root both sides, to get 42.5. So that is how long it is from S to V. That number makes sense because it's the biggest number out of that right triangle. So man, that was hard. So first I had to realize that these two are tangent and congruent and solve for x. Then I had to know if it is tangent, I have a right triangle at the point of tangency. You have a radius that's the same. You found this leg height by substituting it in, and you could find your missing hypotenuse side, your C. Whew. Pretty sure this is hard to get. All right, looking at 13. This is an example of when I got party hats going all the way around. And so I know that all the individual sides are going to be congruent to each other. So if this party hat is 11, well, so is it from D to H. And if HE is 16, then I know EI is going to be 16. And then if IF is 9.5, then I know GF is 9.5. So now it wants me to find the perimeter of triangle D, E, and F, which is all of it. So with perimeter, you're going to add everything up. So you've got two 11s to add up, you have two 16s to add up, and then you have two 9.5s to add up all of that. So if you type that in the calculator, you are going to get 73. And so that is how you can use tangent lines to find perimeters if a circle is circumscribed in a triangle, or a triangle is circumscribed around a circle. The circle is inscribed. All right, let's look at one more example. This time I have 4 party hats going on, and unfortunately they only gave me longer lengths. So what we can do is, if you know this piece is 23, we are allowed to duplicate 23 on the other side. Now, to figure out these remaining pieces, you're going to have to use the knowledge that the entire thing is 37.5, and if you subtract 23, that'll give you your 2 remaining pieces over here. So 37.5 take away 23 will give you this party hat over here, which ends up being 14.5. So both of these sides, I'm running out of room so I can't write it, are 14.5. So same thing over here. You know this piece is 27.1, so its matching side is going to be 27.1. But to move over here and find these 2 lengths, you have to use your knowledge that the entire thing is 52.5, and I want to take away this 27.1 to figure out this remaining piece over here. So if you do that, you will get 25.4. And so you know these both pieces are going to be 25.4. So now I can find the perimeter of my entire quadrilateral from P to Q to R to S. So when I add that, make sure you count everything in. So you have two, well, you can add each one individually, or if you want, I'm going to add this 37.5 in, and then I'm going to add this 52.5 in, and then I'm going to have to take these two individually. Plus 23 and plus 25.4 for this side. And now I have this side, which is 14.5, and then the 27.1. Okay, so that'll give you the perimeter. You can also add 23 twice, 14.5 twice, 27.1 twice, and the 25.4 twice, and you will get the same thing. Okay, but if you do that, you should get a final answer of 180 when you add up all those numbers. All right, and so that is it on tangent lines. So to review, if they appear to be tangent, meaning you have a 90-degree angle here and here, the outside lengths are going to be the same, and you can create a triangle circumscribed around a circle to get all of these pieces the same. And for the heck of it, if you tried number 11, you should have gotten 3 and 29. But thank you for watching more properties of tangent lines, and now you can practice.